Consider an engineer who wishes to optimize the part or product that they are designing. They know that they have many degrees of freedom, for example, geometric parameters, or the materials that they could use to design their part. But they don't know how these different parameters interact with each other and the impact they will have on the final product. The engineer is looking for the best combination of technical performance, sustainability, and of course, cost. At Ansys, we have developed a framework to enable the engineer to do this. It combines high-quality materials data, fast and accurate simulation, and process and optimization tools. These can be linked together to give the engineer a deep understanding of the product they're designing and the impact that their design choices have on the final design. The first step is to have a CAD model of the design. This can be imported into Ansys Discovery, where an appropriate parameterization of the geometry can be made. Secondly, the materials that should be simulated for each component can be selected from Granta MI. These can later be imported into optiSLang using the built-in Granta MI node. Here we can see the Granta MI node within optiSLang. First, the materials are assigned to the correct components, then the right material card is selected, and finally we select any other information we would like to export. In this case, we're exporting price per unit mass, which will later be used in a cost calculation. This example uses Ansys Discovery as a simulation tool. Here you can see the different geometric parameters being added as our model parameters in red on the left-hand side, and the responses we expect to get from the simulation being added in green on the right-hand side. We can also use the price information that we have about the material to do a simple cost calculation. Sustainability analysis is done using the BOM Analytics module, which is included as part of the Granta MI sustainability package. Finally, we set our optimization goals within optiSLang, which are used as targets for our optimization. Following the optimization process, we can see a list of designs created by optiSLang. We can then analyze these designs using optiSLang's built-in post-processing and analysis tools. In these plots, we can see Pareto fronts, which help us understand the trade-offs which must be made to optimize different aspects of our design. For example, here we can see the trade-off between price and maximum displacement. Here we can see the trade-off between climate change CO2 equivalent and maximum displacement. And here we can see the trade-off between embodied energy and maximum displacement. The three different colors represent the three different materials used in our simulations. Additionally, a spider plot can be created. This allows us to see the impact of all the different parameters, both geometric and materials, in a single plot, thus allowing designers to get a complete understanding of how their design decisions impact the overall technical performance, sustainability, and cost of their product.